All right, so we're looking at the Chapter 3 Density Excel, and what we're trying to do is convert these matters, these materials, from the density that's given to us into a new density. So what they're giving us here is helium, and they're saying that helium has a density of 0.179 kilograms per meters cubed, or cubic meters. And we want to convert this into pounds per inches cubed. So we've got some conversions up here. One of them converts from pounds to kilograms, and the other one converts from cubic inches to cubic meters. So this is a problem where I could possibly use proportions, but we use a method that they're giving you in the book called dimensional analysis. And what dimensional analysis is a little bit easier to convert, but you have to think about it a little bit differently. So I set it up over here, and what we're given is we're given this information right here. So first of all, we're given 0.179 kilograms per 1 meter cubed. Even though the one's not written there, it's understood. So when I look at these conversions that I have here, pounds to kilograms, I need to somehow get that kilogram to change to a pound. And I need the pound to be in the numerator. So I put the 2.2 pounds on top and the 1 kilogram on the bottom. So notice I have a kilogram on the top in the numerator and a kilogram in the bottom in the denominator. So the unit of kilogram technically will cancel out, and all I'll be left with is the pounds. And then I do the same thing with the meters cubed and the cubic inches. So I have meters cubed on the bottom. So if I put meters cubed on top, and I put the inches cubed on the bottom, then the meters cubed will be canceling out, and I'd be left with inches cubed. So once I do this calculation, I'll end up with the pounds on top and the inches cubed on the bottom, which is what I want. I want the pounds on the numerator and the inches cubed in the denominator. So when you're working with fractions, what you do is you multiply the numerators and then multiply the denominators and then divide. So what I would end up doing here is I would end up saying 0.179 times 2.2 times 16.387. And then in the bottom, I would end up doing 1 times 1 times 1 million. Okay? And then as my last step, I would end up taking that numerator and dividing by the denominator, and I would end up with my answer. So I would end up with the 0.179. I'm going to come over here once. I would end up with the answer from the 0.179. Actually, I'm going to do it a different way. So let's talk about cell locations. The 0.179 is located in cell C9. So I'm going to have C9 times. This 2.2 is located in B5. The 16.387 is located in F5. Now, the two ones really don't matter, so I can leave the two ones off, and I'm going to do that because 1 times 1 doesn't change anything, but that 1 million is important. So that 1 million is located in E5, so I'm going to put the E5 in there. So this is what I'm going to end up doing to calculate my values for helium, right? So what happens when it's not helium? What happens when it's agraphite? So then what happens is the 0.179 changes to 0.2 kilograms, right? Everything else stays the same. So the only thing that changes is this number right here becomes 0.2, right? This number right here becomes, instead of C9, it becomes C10. So remember what's happened on the last few things. Everything else stayed the same. The B5 stayed the same, the F5 stayed the same, and the E5 stayed the same. The only thing that's changing is the C10. So that means that I'm going to have to use my cell referencing, my absolute references, to make the B5 constant. So we're going to do the same thing with the F5 and the E5. So we want to make those the F5 constant, and we want to make the E5 constant. Okay, so I want you to type that formula in cell D9, and I want you to see what you come up with. All right, so this is what you got for helium, and we're going to take that value, and it tells us in our directions that we need to format it as scientific to any number of decimal places. So it doesn't really care, but it wants to make sure it's scientific. So we're going to come up here and we're going to choose scientific. So you don't see it listed as your option sometimes. We're going to go to more number formats, choose scientific. And the 2 came up default, so I'm going to use that. And we're going to fill this all the way down to the bottom of our chart. Okay, so now our next step. So now it's asking us to, let's go back to our directions. It's asking us to calculate a new scale for helium by setting the density of gold to 100 and calculate the formula. And format is a number with 3 decimal places. So we did this before on the last problem. So on the planet problem, we took Mercury and we divided it by Earth. Well, in this case, we're going to be taking helium and we're going to be dividing it by gold. Gold is way down here at the bottom at C58. So you want to take the helium, which is the 0.179, and you want to divide it by, oops, I didn't do that. You want to divide it by the gold. Gold's way down here at 19,320. And over here in this scaling column, we're going to be putting an X for helium, because that's what we don't know, and we want 100 for gold. So what we're going to end up doing is formatting all of these so that I have the helium or the aerographite and gold and whatever it happens to be. So when I do my calculations, I get 19,320 X equals 100 times 0.179. And then my next calculation is going to be X equals, move my mouse for you, 100 times 0.179 divided by 19,320. Okay, so the 100 is going to be a constant. It's never going to change. The 0.179 is currently C9. And the 19,320 is located all the way down here in C58. All right, so again, when I do my calculations, the C9 is going to change. This time it's C9, the next time it's going to be C10. But the C58 is never going to change. So you're going to have to use absolute referencing. So you have to use absolute referencing for C58. Okay, so absolute referencing, remember, has something to do with the dollar sign. So I'm going to get you to do that. And we want to calculate our gold scale. So I'm going to give you a minute to do that and find our gold scale. Okay, so looking at our steps for step 3, we did this scale for helium with gold to 100, and we filled that down, and we had to set our number of decimal places to 3 decimal places, and it's a number format. So we should have a table that looks like this, and our last value for is, I don't know how to say that, is 116.822. Okay? So now the next step says to do the same idea, except we want to set water to, and it says, actually, I didn't. We want to do fresh water to 100. So for our water scale, we want to, I didn't need to say 100, fresh water to 1. So fresh water is right here, so we're going to want that to be 1. So what we're going to do is we're going to do the 0.179, that's our helium, over 1,000 for fresh water. And then we're doing x over 1. So then when I cross multiply, I get 0.179 times 1 equals 1,000 x. And then for my next calculation, it's going to be x equals 0.179 times 1 divided by 1,000. And then when I do my cell referencing, C9 is going to be, 0.179 is going to be C9. And then the 1,000 is going to be C23. So again, when I'm doing the next value, it should be C10, but the C23 shouldn't change. So again, I'm going to have to use absolute referencing. For cell C23. Okay, and then I can just drop the 1 because that doesn't have any impact on the problem. Okay, so I'm going to give you a minute to type that formula into the water column, and we'll see how you do on that. All right, so make sure you look at your instructions, and your instructions are telling you to format it as a number with 5 decimal places. So make sure that you've got your number with 5 decimal places in for these, okay? And then we're going to look at our chart. So our chart is saying create a clustered column chart to show the densities. Select B8 through C62, okay? So B8 is right here, right? Starting with material, B8 through C62, so we want to start here and select all the way down to the C62. And we want to create a clustered column chart, clustered column with style 6. So we're going to insert a chart. We're going to choose the clustered column with style 6. So there's our clustered column, 1, 2, 3, 4, 5, 6, style 6, okay? And let's look at the rest of our instructions. It says make sure you've got a chart title with density kilograms per meters cubed, kilograms per meters cubed, that looks good. And it doesn't say anything about any vertical or horizontal, okay? So this is our chart, and it's going to go into our area, our chart section over here. And then the last thing that you need to do is look at the decision that they're asking you to make about the scaling, and it says determine whether the scale you use matters when you make a column chart. So you're going to have to make some determinations on that. So you're going to answer that question. Sorry, over here it says does the scale matter, and you're going to choose yes or no for that option. So as a way to check, if you were to make a chart with different scales, if I choose material through 62, remember if I hold the control button on the keyboard, and I think it's a different button for Apples or Macs. Oops. If I choose the control button on the keyboard and then I highlight a different column, so let's say I do this one. So that allows me to highlight two columns that are not adjacent to each other, and then I can make another column chart and see if they all look the same. So that's how you can make a determination about that. All right, so I hope this helps, and you have a great week.